Hello, my name is Alex. I work in QuickField support team. QuickField is a simulation software distributed by the Tera Analysis Limited. Headquarters are located in Svendborg, Denmark, and we have a distribution office in Toronto, Canada. Today, I would like to speak about how C3D kernel helped QuickField to become a powerful 3D electric analysis tool. QuickField is a simulation software, and we have DC, AC, and transient magnetic and electric analysis packages. We have steady state heat transfer and transient heat transfer packages. And we have a linear stress analysis package. These applications are covered by the list of analysis packages. Mostly QuickField is used for the electrical and magnetic simulation of electromagnetic devices, such as cables, transmission lines, electric motors, transformers, printed circuit boards, and many others. Thermal analysis models are used to build thermal models of electromagnetic devices and to calculate, for example, thermal transmittance of the building insulation, to simulate induction heating devices, and others. As you see, list of customers is very diverse. We have all major states and European industrial corporations, research centers, universities. And today I would like to speak about Naval Research Laboratory and their experience using QuickField. Dr. Allen is our customer at Naval Research Laboratory. He has published more than 80 papers. He is a leading researcher at the plasma division of the Naval Research Laboratory. He started using QuickField in 2001. They have ordered electrostatics and DC conduction models. Then later they ordered transient magnetics and heat transfer. They used QuickField primarily for simulation of the devices they used for plasma physics applications. Then in 2013, we released the first three-dimensional version of QuickField, which was based on the free three-dimensional library. And Dr. Allen was one of our first customers who started using three-dimensional features of QuickField. And it soon became obvious that three-dimensional functionality is not sufficient. Main drawbacks were limitations of the single-body topology import, insufficient mesh size, and unstable behavior of the three-dimensional core. So we decided to replace three-dimensional core, and after comprehensive research, we have chosen C3D kernel. It was a huge product and required a lot of efforts, and we're thankful to C3D team for their technical assistance during the migration process. And finally, in 2019, we released the first version, which was based on the C3D kernel. It supported multi-body input from all major card systems in step format. That time, Dr. Allen worked on the complicated project which required three-dimensional electric analysis. And his work resulted in the publication where he refers to QuickField as a useful tool to simulate electric field distribution and to design the electrode system. Courtesy of Dr. Allen and Naval Research Laboratory, we are allowed you to demonstrate what exactly did they do in their project. This is the high voltage switch, and the switch consists of two groups of electrodes. The idea was to replace the conventional oil switch with the water switch. Comparing to the oil, water features very high dielectric permittivity and superior fire safety. The switch consists of two groups of electrodes, high voltage electrode and grounded electrode. The task was to calculate the electric field stress and to calculate the capacitance between the electrodes. So let's start QuickField, and I will show you how it was done. You see, this is QuickField 6.4. It is based on the C3D toolkit. Here I create new project. Call it switch. Next. Problem type is electrostatics. Model class is the three-dimensional import. And here I will import the geometry model from a step file. Here it is. This is the outer body. Hide. This is the upstream body. Hide. This is the downstream body. Hide. And this is the shielding disk. Okay. All these materials are conductors, so I do not specify any electrical permittivity value here. Instead, I will specify electric potential on the conductor faces. Upstream. This is the upstream electrode, and the peak value of the electric potential is 4 megavolts. So this is faces has the label high voltage, and the high voltage potential is 4 megavolts. Okay. Unhide all. Hide. All these electrodes are grounded. So for these electrodes, I assign label 0 and specify 0 voltage. And we need to add the water to our model. Enable the ground region. This would be water. And for the water, I specify electric permittivity, which is 81. Now that's all. The geometry model is ready. All I need to do is to build the finite element mesh on edges, on faces, then to build the finite element mesh in volumes and run the analysis. That is that fast, thanks to C3D toolkit. Well, it takes some minutes to run the analysis, so I'd better switch to the already simulated problem. Here you can see the electric potential distribution, and my task is to calculate the electric stress distribution between the electrodes. So I will use the cut by plane tool, switch on the two-dimensional cross-section window, here I will adjust the field picture and switch on the electric field strength, switch off the isoline plot, and let's zoom in. Now here you can see the electric field stress distribution in space between the electrodes. You can find the exact values by clicking any point, get the potential value, get the electric field strength. You can use the contour tool, draw the line, and get the field distribution along this line on the XY plot or in the table. Again, here you can get the coordinates, potential, electric field strength. That was one task. Another task was to calculate the capacitance. Okay. Close this window, close this window. I will hide the water block. Now you can see the electrode system. To calculate the capacitance, I need to find the charge. That's easy. I select upstream body, follow to the integrals, and this is the electric charge. If I divide the charge by the potential difference, I will get the capacitance. That is how it is done in QuickField. As you see, it is indeed a complicated device that requires three-dimensional analysis. And thanks to C3D toolkit, QuickField has become a reliable tool used by leading researchers to perform electric analysis simulation. Now I think that's all. Thank you for your attention.